somewhere in graduate school, I started to realize that I wanted to uh, really stay in the university. I had come to know the Lord when I went to college as a freshman. And as a result of that, it caused me to really love the university environment. And and then I thought, well, I can just stay here if I become a professor. So that really became my motivation at that point.
Well, as a chemist, although I can't compare with you, I can fully understand why one would love to do chemistry and really dive into it. Second question is away from particularly chemistry, and it's more about your academic environment. Which challenges do you meet or did you meet when you decided to become a professor at university?
You know, God had blessed me so much, so much. My group took off, my papers took off, my funding took off very, very quickly. The Lord was very good to me. And I started making it known that I was a believer. Right at the beginning, the first exam that I ever gave, I put a scripture verse at the top, and I've maintained that practice now for 35 years. Put a scripture verse at the top. I was once called to meet a philosophy professor, and I think I was in my second year at the university, and he said to me, he said, I can't believe you're putting a Bible verse on your exam. I heard about this. He said, you would never get tenure in my department if you did that. And I said, I've never really even thought much about tenure. I just figured I'd do my thing. And interestingly enough, after 3 years, I was granted tenure, which in the American system is very fast. And then after
Hmm.
4 years, went from associate to full professor. And after 5 years, I was given a chaired professorship. So I didn't even concern myself with any of that. And I just lived my life, and I gave out a written testimony to students at the end of each semester that they could take a copy of my testimony. This is before the internet was really in
Hmm.
swing. So we handed things out on paper at that time, and I never really concerned myself about it. I got a little pushback, and it was just a little. It was nothing to really worry about, and that's kind of
Hmm.
how my career has been. Any pushback that I've gotten has been minimal pushback compared to what the scriptures talk about. As the writer of scriptures say, I've never shed blood in my testimony for faith. People have threatened me that they were going to punch me in the nose, but they never did. So based on the level of what the scripture calls us to, I've never really had any particularly frightening sort of attack.
Amazing grace in a university professor's career, I would say. Now, obviously, you put Jesus on top of your concern even after you had started your university career. So, presently, which role does your trust in Jesus generally play in university? How do you decide which research topics to choose? How does it influence your interaction with colleagues and your research students and with undergraduates? Which role does Jesus play in your work as an academic,
Wait
as
a
a
minute, wait a minute.
professor?
You're asking me too many questions at once. Take them one at a time, and I'll try to answer them quickly. What was the
Okay.
first one?
It's actually about the role Jesus plays and how you interact with colleagues,
Okay,
science, and undergraduates.
the role that Jesus is first in everything. I love him
Mm-hmm.
so much. Jesus is the
Mm-hmm.
best. I mean, this is the Son of God has come to earth. God took on flesh. The Bible says that he took on flesh because his children are of flesh. We have a big cancer hospital, the biggest in the world, right here in Houston. And so many times, a child will be undergoing chemotherapy, they lose their hair, and the mother and or the father will shave their head in solidarity with that child to say, we're in this together. And Jesus took on flesh because his children bear flesh. We have flesh. And he is so kind and so gracious to us in every way. I can't imagine not telling people about Jesus. I can't imagine going through my career and people not knowing about how much I love Jesus. It impacts my science because, I don't pray that just my reactions would work and nobody else's. In my field, if I say something works, it has to work for everybody. And so I pray that just God gives me wisdom for me and for my students, that he would make me like Bezalel, this man in Exodus 31, who was a craftsman who who had been called to build a tabernacle. Moses had commissioned him to build a tabernacle, and the Bible says that I've called Bezalel, the son of Uri, the son of Hur, of the tribe of Judah. So God was very specific. He knew exactly who he was, who his father was, who his grandfather was. He says, I have filled him with wisdom, with understanding, and with knowledge in all types of craftsmanship. So first he gave him wisdom, because if you have knowledge without wisdom, you can do dastardly things. And he gave him first wisdom, and then understanding, and then knowledge. And then you just look at the list of the things the man had. He could work in gold, in silver, in bronze. He could work in stone cutting and stone setting. He could work in wood, in fabric, and perfuming, and he had the ability to teach it. I said, Lord, make me like Bezalel, and let me work across many different fields. Do this for my students as well. Colleagues know where I stand. Some of them talk about me, but it's rarely to my face. It's behind my back, so I don't hear it anyway. And they rarely talk about this to my face. And I've shared with many colleagues over the years, and I share with many students all the time. Every week I'm sharing with students. Every week, multiple times a week, I'm sharing about Jesus with students. So that's kind of been my life.
Did the Bible or Jesus um, inform you on a particular research topic which you chose?
No,
Did you
no,
ever
I
connect this more or less directly to what you just explained about your faith stance?
can't say that I read a verse in the Bible that, prompted me to work on
Hmm.
carbon, that prompted me to work on molecular machines. But he drops in thoughts, he drops in ideas, and very often they're not my ideas. They're ideas that my students have.
Hmm.
Once in a while, I come up with something, but it's more common that they come up with it, and I thank
Hmm.
God for that, because I pray that God would fill them and God would use them. So it's not like I got a particular Bible verse that
Hmm.
cued me in. Sometimes God certainly speaks through the Bible like that, and He's done that on numerous occasions in my life in other areas, but I can't think of an area offhand right now where he spoke to me through a particular Bible verse,
Hmm.
prompting me to work in a certain area.
Or did you ever feel like you should avoid a certain area of research? As a
Oh, I
Christian,
mean,
I mean.
I, I,
Hmm.
I mean, I've avoided collaborations with certain people. I've avoided
Hmm.
working with certain people because of senses that I've had, or particular things that I've prayed. And then when I'm reading in the scriptures, I see what appears might be a warning. But he has not steered me away from any particular area through a particular Bible verse. He certainly can,
Hmm.
but he has not done that in my life.
Thank you. I think we got to move on to our next big topic for this interview, which is about the origin of life or origin of first cells. This is something which you've spoken about publicly very
Yes.
often, have engaged in debates. So you're not actively doing research in origin of life issues, if I'm not misinformed. How is it that you got so intensely involved in the origin of life debate and research?
I didn't intend to go this way. It's made my life a whole lot more complex. I was invited to a meeting, and I saw a presentation on carbohydrates, and it was just utterly amazing. And I
Mhm.
remember walking out. There was a break, and I walked out, and a friend of mine, David Berlinski, was standing out on a veranda, and I started talking to him. I said, David, this stuff is so amazing. He says, why don't you write an article about this? Just write an article about the things that you're seeing that other people might not see. So I started to look into evolution, and then I wanted to track this thing back. And so I went back and found out that there was this whole area of abiogenesis. And so I started to ask my colleagues, my synthetic chemist colleagues, I said, how did, how is it proposed that life began? How did this whole thing start? And they directed me to the work of Albert Eschenmoser, some organic chemists that have worked in this, and a few sent me other papers. And I started reading these. I said, this doesn't make any sense. I mean, this doesn't work. This would never happen on an early Earth. You did this in a laboratory, and even doing it in a laboratory, your results showed you couldn't do it. So if anything, it showed how it couldn't have been done. And so then I started tearing into the literature and reading all
Hmm.
sorts of things.
Hmm.
And then I saw that most of the literature shows how life could not have formed because there's so much human intervention, so much setting of conditions that this could never have formed. And then there's one thing after another that would stop this thing from ever working. And so then I wrote this article for David Berlinski, and it just blew up. Everybody got interested in it, and I was being invited to speak. And then I wrote another article, and I think I've written like 5 articles on the nonsense of the proposals on origin of life. It certainly happened somehow. Uh, um, so the question is not, can you go from non-life to life? I mean, we're certainly here. So in that sense, I mean, the life is ubiquitous on this planet. But any other planet, any other place we've gone, I mean, there's no life, and that's actually what you should expect because this is such a hard thing to get going. So this is an anomaly, and I started to write about this, and then I realized that I was causing problems for other people's careers, which was never my intent. I was just sharing about the way I was seeing it, and so then one thing led to another after that.
Could you perhaps summarize, particularly since we have a mixed audience of chemists and non-chemists, could you perhaps summarize what you think are the main reason that the present models for the origin of life don't offer a viable explanation?
The vast majority of compounds in nature are handed. They have a chirality to them. They have a non-superimposable mirror image like your left and your right hand. It's very hard to make compounds like that uh, and to get one-handedness. And it's even hard to crystallize them like that. Once in a while they do, but the vast majority of them do not separate into different crystalline forms. And even if they did, how would you then separate the two different crystalline types, one from the other? It, all of these are hard questions. And some people have suggested, well, nature started with racemic mixtures with both the left and the right-handed, and then it optimized after that. We know from work in chiral-induced spin selectivity that could not have happened. You had to have had the start of life with chiral comma. So you couldn't make the basic building blocks of the building blocks, the very basic structures. Then a big problem is polymerizing those. How do you get them to hook together? So how do you take amino acids and make polypeptides out of those? Polypeptides being proteins, being all of the vast majority of our enzymes. How do you do that? And experiment after experiment, people have tried. And it's hard to get these to go because something called the free energy. The free energy is positive. So when the free energy is positive, they favor the starting material. They go back to the starting material. All of these are condensation polymerizations, meaning that you are ejecting a water molecule every time you do a coupling. But you have to do the reaction in water. So what chemists have thought of is that you have ways of activating this. And this is what biology does. This is what chemists do. But before you have biology and before you have chemists around, how do these go together? And the other problem is, even if you could get them to couple, and you can only get it to couple poorly because they go back, is that they have extra chains hanging off them, extra groups on half of the amino acids, which would gum up the works. They cross-link, and then the thing is dead. And they're just as reactive as the two normal ends for the polymerization. So the polypeptides are out. If you look at the polynucleotides, which are DNA and RNA, same sort of problem. If you look at the RNA, there's an extra hydroxyl group, and that hydroxyl group is at a 2 position, at a 2' position rather than a 3', and that causes the polymerization not to work properly. And plus, through that extra group, you get other branches coming off it, so it would be an unusable structure. And then the carbohydrates are the absolute hardest class because the carbohydrates have so many different ways that they could hook together, even if you could get them to hook together. So you have to figure out some way around the thermodynamics of the free energy. And that's a real problem. But even if you could, you have all these extra ways that it could assemble. So if you just take, for example, glucose, if you just take 6 glucose molecules, how could you hook those up? If you had, say, 6 letter A's, how could you hook that up? It'd be AAA, and so forth. And then you could have the branching components of those. But for glucose, you can hook that glucose up, 6 glucose molecules over 1 trillion ways, because you have 6 open member ring, 5 member ring, open form, closed form. You can hook it any one of the different hydroxyls over 1 trillion, it's 1.2 trillion ways. Just 6 glucose. You get that thing wrong, the cell doesn't work. If you get that wrong, how does that happen? Nobody knows. The Leventhal 1.0 problem. How do you get the proteins? If you had, let's just say one happened to fold in the right, one happened to form with the right configuration, which is much smaller. If you had, say, a 100-mer polypeptide, how would you get this thing to fold up? The vast majority of them don't fold on their own. You need some sort of helper there. But even if it did fold, how long is it going to last? If you think of RNA, how long does it last? Many people come up with this RNA world hypothesis. If you had a 600-mer of RNA, which would code for a 100-mer protein, so which would code for a 300-mer protein, just if you had this little RNA, how long would that little piece of RNA, if one happened to form of the right size, it would last hours. Generously hours, if there were no metal ions around in water. So these things hydrolyze, because what you have to do is you have to take the half-life of what we deal with, because as chemists, we deal with moles of molecules. Excuse me. We deal with moles of molecules. We don't deal with individual molecules. So you have to take that big number, and you have to say, I'm going to bring it from a half-life, which is the way we normally talk about it, and I'm going to bring it to a probability. So when you scale that thing down to a probability, when you have one molecule, what you see is that RNA would last for hours. A polypeptide, a protein, an enzyme, would last for days only in water. And so once the thing is made, now all of a sudden, you've got to be able to bring in all the substrates that it's going to act upon, because it's undergoing hydrolysis. So even if you had one that formed, you had the right chain, which is less than 10 to the 50th. So it's outside the bounds of time in the universe. But even if one happened to form, and you can't get the polymerization to form anyway, but let's just say somehow it formed, which we have no chemical way of knowing how that could have happened, and it was a linear system and not all cross-linked, then it would only last a few days. I mean, that's it. That's the problem with these things. Now, then you have the Leventhal 2.0, which is if you are going to assemble a cell, you have to have the non-covalent interactions between them. And in a single yeast cell, just the protein-protein interactions, not my calculation. These are biophysicists' calculations, just the protein-protein interactions in a single yeast cell, which is a simple cell. You have to have, it is 10 to the 79 billion possible combinations of non-covalent interactions. And only a few of those are going to work. I mean, 10 to the 79 billion is so crazy big number. You could have 1,000, you could have 1 billion universes, and it's not enough time to make this thing happen. So these numbers are staggeringly against you. Then, even if you had all these compounds, because we can take a cell today, we can take a cell and deconstruct it, bring it back down to the amino acids, to the nucleotides, or we can just leave the polymers together. So you have the polynucleotides, you have the DNA, you have the RNA, you have the proteins. And I just take these things apart and I say, go ahead, put it together again. Go ahead, put it together again in your lab. Forget about under a rock. Forget about in a pool on the side of the ocean. Just in your lab, could you take these components that I just took out of a cell? You already have the code, because I'm giving you the DNA. I'm giving you the RNA. You already have all the code for everything. Could you assemble these into a cell? Nobody would say I could do this. If you could do that, you'd win a Nobel Prize that same year that you did it. I mean, it would be so extraordinary to put the components together. But even in my giving you the components, I gave you the code. Where did the code come from? Nobody knows where the code comes from. And every time a cell divides, it takes that information and puts it on each side, and it separates this. And so you see this sort of thing going on here, and it's just fascinating, just fascinating. Nobody has answers to any of these things. So you wonder, what are these folks up to?
It seems that there is no chance of finding a non-interventional origin of life in the future. Would
But
you
even
agree?
even in interventional, I'll give you all the
Mhm.
pieces, just assemble it in your laboratory. Nobody would say that they could do this. Nobody. Even if you give in all the pieces. So even with an interventional, we can't do it, let alone an interventional, let alone without a laboratory. And people say, well, a lot of these compounds come on meteorites. Okay, let's think about that. What comes on meteorites? What comes on meteorites are gross mixtures of compounds. You never get a unique compound. It's a gross mixture. Generally, they are optically inactive, so you don't have the proper chiralities. And when they're optically active, the optical rotations, the optical activity is very low. The degree of chirality is very low. In the highest cases, it's been like in the 60 percentile, which would be way too low. It has to be 100%, 99.999.
Mhm.
But even if we give, and those ones that they have found were never the right ones. They were diastereomers of what we would need for life as we know it. But even if these come in such gross mixtures, and that's why even John Sutherland, an Origin of Life chemist, will confess that the meteorites don't give you the right mixtures because as chemists, we don't know how to do chemistry with vast mixtures of compounds. Biology does. You can take a handful of supplements at breakfast, and your body knows what to do with each one of those supplements. It just goes into your stomach
Mhm.
all at once, and it has enzymes that selectively pull these things apart and know exactly what to do. Chemistry's not like that. You have mixtures of compounds, everything gets gummed up. You can't make saccharides or do the polymerization of saccharides in the presence of amino acids. It can't be done. These interfere.
Mhm.
You can't make amino acids or the polypeptides in the presence of saccharides. It can't be done. So what these folks want to do is they want to have everything in a pure bottle, because this is what we have to do. And then after they have their substrate, then they want to bring in the next substrate, because we can't do it on. That's all meteorites deliver. So this nonsense that the meteorites delivered it is just a bunch of nonsense. The other thing is the throughput problem. When we do synthesis in the lab, you do reactions and you optimize the yield at each step before you go on, because you have to carry it on many steps. How many steps would you need to go from methane, from carbon dioxide, from water, from ammonia? How many steps would you need to build a living cell? I mean, thousands of chemical steps. But what happens is, if you even if you had 50% yield at each step, which is pretty good in a laboratory, the first run through, 50% yield. So you go from, say 1 gram of material, and let's just say that instead of dealing with moles, we'll say the molecular weights are about the same, and so we'll deal with weights. So we go to half a gram, a quarter of a gram, 0.12 grams, and all of a sudden you run out of material. So what do? You go to the lab and you make more following the protocol that you had, but you scale it up and you optimize it each step. So you bring that yield from 50% to say 90%, and you have to keep bringing up starting material from the rear. But if you never kept a laboratory notebook, because nature doesn't keep a laboratory notebook, nature runs out of material. How does nature go back and make more? I don't know. It doesn't know. It's lost. So it spent,
Mhm.
say it spent 100 million years making a compound. Now it ran out of material. Well, you're out of luck, nature. You can't go back and make more. Nobody has an answer. Everything that I have proposed to you today is a problem. Nobody has an answer to this unless they don't know chemistry. If they don't know chemistry, they have all sorts of answers. But no chemist, no organic chemist has an answer to this. This is why I'm calling them out. You guys answer it, I tell them, because the chemists can't answer it.
I have a very specific question to you, James. You being a very erudite chemist. It's a purely physical chemical question. How do you answer to claims that electron spin explains the origin of homochirality? This was Ron Namann's work. He was also at the conference in Nazareth 2 years ago, which both you and me attended. And do you have an answer, or can you point to literature to
Oh,
answer
it
that?
doesn't explain the origin of
Hmm.
chirality. It does not.
Hmm. Hmm.
What Ron Nauman explained is
Uh-huh.
that you had to have had chirality in order to have life. The electron spin doesn't get you that chirality. There's no way. The electron spin and the differences there were orders of magnitude off of what you would need to have electron spin giving you chirality. We have no examples of that. And if you could, in a laboratory, very carefully do this, you would only be able to do it with maybe one compound, not an entire class of compounds, let alone a broad array of compounds. But the chirality, what Ron Nauman has shown is that you have to have chirality already in order to give you these spins. And so that you have a spin up and a spin down, and the selectivity comes because you have these chiral molecules. So you had to have chirality before you could have had life. But I will give you all the compounds with complete chirality. I'll give it to you. Now what? How are you going to polymerize them? I don't know. So if anybody wants to dig in their heels and say, I could get all the classes of compounds, I'd say, go ahead in your laboratory and do it. You win a Nobel Prize. Go ahead in your laboratory, let alone under a rock. Do it in your laboratory and try to take some electrons and somehow, without taking a biological system, without taking some human-made system, get that to give you spin polarization such that you start generating compounds with high enantiomeric excess. Go ahead, do that in your lab. You'll win a Nobel Prize, especially if you can do that over an entire class of compounds. So I'll just give you that, though, because I'm a nice guy. I just give it to you. Now what? How are you going to polymerize them? This is so frustrating to me, in the sense that it's so nonsensical to anybody who does chemistry, that to claim that this sort of thing works. Nobody in their right mind who knows how to do chemical reactions would suggest such things. And that's why these guys just avoid me. They just avoid me. And they won't debate with me. They won't even talk with me. They won't discuss with me. And if there is a discussion, they'll totally avoid the topic at hand, because there's no answer to any of these questions.
I would like to close with a question on this topic of the origin of life, picking it from the chat. I'll pick one question from the chat before I hand over to Alexander for another set of questions. There's a question in the chat, James, which says, do you believe that God actively intervenes in the universe to create life, or basically wound up a fine-tuned pocket watch in the beginning?
Let me first say that I have never approached the origin of life question bringing God into this. I don't have to. Every one of the chemical questions that I put before you, I never mentioned God. And there's multiple reasons for that. One of the reasons is I don't have to. The chemistry itself screams out, didn't happen this way. And the other thing is, if I mention God in it, people will say, "Oh, he's God of the gaps. He's a religious guy." And the last word that they're allowed to call you, derogatory word that they're allowed to call you in the university, they can't pick on my religion. They can't pick on my nationality. They can't pick on my skin color. All of these are taboo, but they can still say, Tour's a creationist. That's the last word. And when they say Tour's a creationist, then on that basis, they want to dismiss me. So I never bring this in. But you ask an interesting question. Could the whole thing have been wound up and set to go this way, or did God actively intervene? It seems to me that God, if I look at the biblical record, if I look at the record in the Bible, that God intervenes on the part of humanity all the time. He intervenes in life all the time. I mean, this is the whole reason that I pray to him, that I intercede on behalf of people, that I intercede on behalf of situations, that I intercede on behalf of elections that my country is going through, because he intervenes on behalf of humankind. This is what we see throughout the Bible. People cried out to the Lord, and the Lord answered their prayer. So God is an intervening God. He does not just set in motion. He intervenes all the time. And he sometimes he brings in the miraculous. But when he brings in the miraculous, he tells us. I mean, there are certain things that nature has, but then he brings in the miraculous. So God, it seems to be an intervener. Just to have set the thing in motion, to have rolled this way, it doesn't make sense to me scientifically, because I don't see how the thing would just roll into motion this way. There's too many things. So you get the amino acids. Now what? If there's not someone to intercede on this, how do they polymerize before there's biology? I don't know. I mean, you got to deal with the free energy problem. It looks like he'd be fighting himself, because he set in motion free energy, and the free energy is positive, so the reaction doesn't go. But the reaction's he's got to somehow make the free energy to go negative to get this thing to go. I don't know how he would just be able to kick this ball and let it get going if he didn't intercede along the way. It just doesn't make scientific sense to me.
Thank you, James. I think this is a good point to ask Alexander to continue with the last set of questions that we have prepared. It's on debates, and while Alexander will interview you, I will have a look at the chat and pick a few questions if we have time then to pose to you, James. Alexander, please.
Thank you very much, James, for giving us a little insight in your academic career as a Christian and also in the origin of life. We leave that a bit now because one interesting thing is that you not only were active in apologetics of origin of life, but even though you mentioned they avoid you and they don't debate you, they have actually done. There are some debates on the internet even that we can watch. And so my question is, how did you get there? How did you get into debating other scientists on the origin of life? Did you choose it? Did they ask you to do it? How did that happen? Because a lot of us might think, I would love to do that, so how do I get there?
Okay, so I'm the last person in the world that you should be asking about debating. I never took a course in debate. I've done one debate, and that was with a YouTuber. And what I realized in that is that first of all, I just got as you can see, I'm very excitable, and that's just kind of the way I am, and it's hard to quell that, and that doesn't work well in a debate. Everything I've read is that you shouldn't get too animated. But the other thing was that I quickly realized the man knew nothing. He couldn't understand what I was saying. He was reading a script. When I looked over, he was reading a script, and I had studied his videos on origin of life, so I knew them. I watched them so many times. He was reading the text from the videos. That's all he could do. So every time I would present a problem to him, the coupling of amino acids, he says, I don't have to go to the board and show that. Here's a paper. And I said, that I've read that paper. That paper doesn't. He says, it says it right here. You can couple amino. I said, but not with the active side chains. He couldn't get it. So I will never debate a person again who is not a chemist, because it's like trying to put a fish hook in Jello. It just comes right out. There's no way for me to engage with them. Then Lee Cronin agreed to have a discussion. It was not really a debate at Harvard with me, and had it been a debate, I was under real constraints because he was concerned that I would become animated like I did at that thing with the YouTuber, and I said to the organizers, well, I won't even do anything unless I'm asked a question. I mean, because just through questions I can communicate what I need to. I'll give my statement and I'll just wait for questions. Well, there were no questions that came to me, number one. So that was a way of restricting me from saying anything. There were no real questions on any of the content. But number two, he answered none of the questions. I put before him a number of different questions. Had this been a debate, he would have been forced to address those questions, but he spoke on assembly theory. And assembly theory doesn't tell us anything about the origin of life. He says something has a causal history. Well, he's going to have to do a little bit better than that. So I really never had a discussion, but I have tried to have discussions with so many people. And Lee actually, to his credit, showed up there. Uh, um, and that was very, very hard to get him there, even though it was just down the road from where he was staying. He was at a meeting already in Boston at the time. But in any case, I've put before it, there's nobody who will engage with me. I've tried to have discussions. I said, we just have a discussion. Let's not have a debate. Let's just discuss this because I want to hear from you how you think this would work. Lee Cronin has said the primordial soup model is a good model. Okay, I would love to hear how he would get the molecules to come together. And I have already given them all the molecules in 100% chiral form. I've already given them. Just tell me how these things go. How would the cell, how does this happen? Nobody knows. This is why they avoid me. If I were them, I would avoid me too. There's no answer to these things. So I'm not a very good debater because I'm too hot-headed. I mean, I've tried not to be. I've really tried to. And the only way I could not be hot-headed is if I'm totally under restriction, like I restricted myself to at that Harvard discussion, that I would only ask questions that were posed to me, that I wouldn't challenge the things that he said, only ask questions of things that are posed to me. So you're asking the wrong person. Ask Dr. John Lennox how to debate. I mean, that guy is as cool as a cucumber. He's just fine.
So, but some of us might be similarly excitable, or I mean, probably most of us have had such experiences, not on YouTube debates, but maybe in personal debates. So, what advice do you have when you are in a discussion with someone who has a completely different opinion or does not really understand your point? How do you get a Christ-like character across and not just hard arguments in order to put your opponent down?
If they're not a chemist, I don't engage them on this subject because they're unable to understand it. The chemistry cries out, this does not work. The chemistry cries out. The chemists, it's no problem for me. I don't engage them because they will not engage me. You'd think that they want to have a discussion. No, they won't even discuss it with me. I have colleagues that come to me and say, look, Jim, I've watched your YouTube videos. I agree with you. Don't use my name. I don't want to have to go through what you've gone through. But I agree with you. Everything I put, it's so obvious to chemists. So I don't have to engage with them. Either they agree with everything I'm saying, or if they disagree, the reason they don't engage with me is because they don't disagree with me. They actually agree. But they have made their living talking about origin of life, or they want to believe that we understand this. But they know, because as soon as the chemist hears me, as soon as the synthetic chemist hears me, they agree with me. And that's why when I try to engage with them, they will not engage. There was a very rich man. He had David Berlinski be the intermediary. He approached a number of world-class people in origin of life research. And this very rich man was going to pay for us to meet anywhere on earth that we wanted. It could be in Paris, could be in London, any city we wanted to. He would fly us there business class, limos all the way. He'd put us up at the hotel just to have a discussion. What would it take to say that we are on a path to solving the origin of life problem? Just deal with these things and deal with some of the things that Jim Tour is putting forward. He could not get a single one of them to agree to this. I mean, everything was paid. He would pay for the whole thing. Nobody would agree to it. Some people said, well, Jim Tour is too religious. That's slight as his opinion. One person said he's a creationist. Another person said it would be no use. Another person said, well, I would only do it if I didn't have to defend anything I've written. I mean, this is silliness. This is just silliness. And so they will not engage. And the reason they won't engage is because they see it. It is so obvious to the chemist that this cannot work. None of the models that they have proposed, we're going to have to come up with something totally different. And I've never said it can't be done. I never have. I just said that all the models that we have won't do it. And I presume one day we'll get this thing figured out. But it's so far from today. Take any model they want. You can take the metabolism first, RNA model first, protein first model, any model you want. You can take hydrothermal vents. You want that? Let's describe it. Any one of those in 3 sentences, I can tear them apart. And they know it, so they will not engage with me. And it's not that I haven't asked. I've asked for engagement. They will not do it. And many people have asked on my behalf. So many people say, well, I say, you invite them. I got invited by a big program in Europe to debate a chemist on this program. And I said, here's a list of 15 names of people that work in the area. If you can get them, I will come. I will do it. And I said, but none of them will agree to it. And the producer of that program said, oh, don't worry, I'm very good at this. He's never come back to me. Never come back.
Wow. Okay, then let's maybe leave the topic of debates. I would
Okay.
like to ask you one question of the chat, which I think is very important, because you shared with us how you share your faith very openly with your students, with your colleagues. You have even led people to Christ in your office. And in Texas, this is possible, obviously. But the question is, what would you recommend to researchers and professors who live in countries where mentioning religious content in the context of a university is against the law? For example, in France and other laicity states, or maybe in countries like Muslim countries and so on, where it's difficult to introduce Christian topics into the classroom. What would you say to these people?
Last year, in 2003, through one-on-one witness, I led 107 people who did not believe in the physical resurrection of Jesus Christ to the point of confessing to the resurrection of Jesus Christ and praying with me to receive the Lord, getting involved in daily scripture reading and in Bible study. 107 people. So it certainly can be done. And that was not that I would say of that 107, maybe 20 of them were in Texas. I would say half of them were outside the United States, and that included Muslims, that included Muslim women who had contacted me through Zoom, that included people from China, people from all over the world. So I do it anyway. Yes, I'm sitting comfortably in Texas, but when I travel abroad, if somebody asks me, I'm going to share with them. Um, uh, I don't want to get into the hypothetical. Well, what would you do if you were sitting in Saudi Arabia in front of I don't know their mosque or something? Would the vast majority of conversations that you have in Europe, and I've shared with a lot of people in Europe and a lot of people in the Middle East, it's one-on-one. You're talking to somebody. You're not going to get arrested. You generally have a relationship with them anyway, and they're just inquirers. So I think many times people hide. They hide from doing this because for other reasons. So, for example, many people, many believers in the United States never share. And well, I don't want to offend anybody. In the university, I won't be well accepted. Well, Jesus had answers to this sort of thing. He said, if any of you are ashamed of me, if you're ashamed of me and the gospel, if you're ashamed of me and the gospel, he says, I will be ashamed of you when I come in the glory of my Father and his holy angels. If we're ashamed of him and the gospel, he will be ashamed of us. I don't know what exactly that means, but when he's introducing us to his Father, I don't know if he'll say, well, Father, you don't want to meet this one. This is what Jesus said. And people have a tendency to hide behind this thing. So something happens to you. So what? So somebody gets upset with you, gets offended. I mean, Jesus offended people all the time. In Luke chapter 11, the religious lawyers came to him and said, when you talk to the Pharisees like that, you offend us too. And Jesus didn't say, well, offend, I'm so sorry. The worst thing I could do is have offended you. I'm very sorry. But no, Jesus said, you lawyers, you're responsible for all the deaths from Abel all the way to Zechariah, all of them. You're responsible for all of them. I mean, Jesus had no patience for this thing. Somebody was offended, he just blasted them. He was telling them the truth. If you are ashamed of me and my word in this sinful and corrupt generation, I will be ashamed of you when I come in the glory of my Father and his angels. I mean, how much more explicit could Jesus be? I mean, yeah, Jim Tour's a hothead. Don't listen to him. But how about listening to the words of Jesus? Jesus said that if you are ashamed of me and my word, I'll be ashamed of you. I mean, how could you not share? How could you not open your mouth? This is criminal for us as believers to not open our mouths and to think that, well, I'm in Europe, I'm in London, and I can't do this, or I'm in Germany, there's laws against it. Nobody's going to throw you in jail because you started talking about why you believe in the resurrection of Jesus. I mean, it's not going to happen. And if they do, okay, big deal. You're in jail. All the apostles they were thrown in jail too. So you're in good company.
So James, I suppose you know about this big European research project funded by Max Planck Society.
Yes.
Well, they want to come up with a very simple cell built out of synthetic materials by 2028.
Yes.
What's your response to this?
Well, first of all, the cell that they're going to make is going to have very little, if they succeed on this, it's going to have very little relation, in my opinion, to any of the cells that we have today. And people will say, well, our cells today are very simple. Actually, our simplest cells today are very much like the simplest cells that we can identify, the earliest cells that we can identify in the fossil record. Because there have been calculations by biophysicists on how simple a cell could be and still survive. And you have to have so many, like 15 different components in there. And even at that simplicity, it would have to get all its amino acids from outside. And so these things are so complex to run. What they will do, they might take some sort of silly little blob of a lipid bilayer, like what Lee Cronin does, and poke at it and see that it divides and it divides. This is called a Marangoni effect. I mean, this is a bunch of nonsense. What happens is you hit a critical limit and then the thing breaks up. And you say, well, it looks like cell division. It's not cell division. There's nothing in there doing the cell division. This is pure thermodynamics, and it's a Marangoni effect. It's been known for 100 years. They'll do something like that if they succeed at all. They remember, to really have a cell, to really have, not my definition, you have to have respiration. You have to have homeostasis. You have to have passing on traits to offspring. It has to reproduce. It's got to have all of these features. If you look at the features that are going to be needed, not by my definition, but by I don't think that they're going to succeed. I wish them well. I wish them well. And they're going to use AI, and they're going to use all these sorts of things. And they're going to, and if they want to build it out of components that we need, if you want to build it out of silicon, fine. But if you want to build it out of components that we know make up life, which are these 4 classes of compounds, and Jim Tour didn't come up with this. This is what the cells come up with. You have to have the lipids. And somehow they've got to get these lipids made. And you have to make the polypeptides. You have to make the polynucleotides. You have to make the polysaccharides. You have to have these 4 classes of compounds, and you've got to get these somehow working together. Good luck with that. It's a hard problem. I don't know where they're going to start. Are they going to take a cell and isolate all these components and try to put it back together? Maybe so. I think still then they're going to have trouble. Or are they going to try to build this thing up as you would on an early Earth from methane and small molecules like that, ammonia, CO2, oxygen? Are you going to try to do it like that? I don't know exactly where they're going to start, but it's a rough problem. And my guess, it's going to go the way of all other efforts like this. And you can dump in, I don't know, what was it, tens of millions of dollars into this thing. And I mean, these are my friends. I'm not against them. Case Decker is a friend of mine. He's not an enemy. He's a friend of mine. And I wish him well on this. I just don't think that he understands the magnitude of the problem because he is not a chemist. He is a superb physicist. He knows so many things that I have no idea of. But when it comes to putting molecules together, this I know. So I don't know where their starting point is going to be. And if they're going to do this in their computer, that doesn't work. I mean, that's not fair. I mean, you got to actually build something.
Thank you. Alexander, I think perhaps we can continue with a question which is not about avoiding to be fired or avoiding to offend people. But there is a question. I'll read it out to you, James, which asks the same question from a different angle. How do you deal with the fact that others cannot understand God's involvement in this issue being God's intervention in creation, because they simply do not understand the issue and are not willing to engage in it in such a way? Because this also happens in other disciplines such as mathematics or structural analysis. So if people don't understand how is the connection between what science does and that this is indicative perhaps of a creator, how
No,
do you deal with people that don't understand?
I agree. If you don't know the chemistry, it's hard to understand why I'm saying what I say. The chemists understand this, but the same thing happens to me. I understand the simple mathematical side. I understand what a big number means versus the time of the universe. But there's other things in mathematics I don't understand. I saw somebody recently, start showing this equation of all things or something. I mean, I couldn't follow him. I mean, it's just I just had to listen to what he said. I couldn't follow it. You take some of these cosmological arguments, the fine tuning of the universe on some things, and there's things that I don't understand in these areas because I'm a small molecule chemist. I mean, this is what I do. So there's areas that I don't understand, but the scriptures, God is accessible to everyone. God comes to us, and he comes to us in a person named Jesus Christ, and he explains to us in very simple terms how it is we have a relationship with God. And he doesn't just explain to us, he demonstrates it for us. He demonstrated this for us. So I don't expect the world, the common person, to understand what I understand on organic chemistry and to appreciate what I'm saying. That's why I'm calling out the expert, and I refuse to debate anybody who doesn't have a PhD in chemistry or biochemistry. I refuse, because they just don't understand. We're going to talk past each other, like what happened to me with that YouTuber. I was just talking past him. So I don't expect you to understand. But as far as God's involvement in this world, once you taste of the scriptures, once you start studying the scriptures, you will see the magnanimity of God and how he touches all facets, and he will touch all of these points in your life that are so different. And here's what I urge you to do. I don't want to leave this somehow ethereal for you. I want you to pick up the Gospel according to John. That's the 4th book of the New Testament. And I want you to start reading in that Gospel, reading it very slowly. You read the first verse. In the beginning was the Word, and the Word was with God, and the Word was God. Stop. Read it again. In the beginning was the Word, and the Word was with God, and the Word was God. Stop, and then take it in segments. In the beginning. Think about that. In the beginning. That means before there was anything. In the beginning was the Word. That's information. In the beginning was the Word, and the Word was with God, and the Word was God.
What do you say about the gospel, about Jesus during your lectures, in lecture time? What do you consider appropriate or legitimate, as opposed to a personal meeting in your office or elsewhere?
I never bring Jesus into the classroom in that way.
Mm-hmm.
Once in a while, I might say, I mean, this just happened the other day. I was trying to explain the difference between R and S, which are the ways that we describe chirality from the Kahn-Ingold-Prelog rules, from what the actual chiral compound is, the arrangement of the chiral compound, the structure of that, versus how we define it. And I said, the definition of it, the Kahn-Ingold-Prelog rules, these are human-made rules. The structure of the molecule, this is from God. Boom. That's as deep as I go in a secular classroom. That's as deep as I go. I don't bring Jesus into the classroom. That's me, because I'm not hired to teach on Jesus. I'm hired to teach organic chemistry. So I stick with the topic at hand. Now, I teach a Bible study to students that I've been teaching for 25 years. And I got like 100 students coming to the Bible study, and I don't talk at all about chirality. I talk about Jesus.
So thank you very much. We only we don't want to exaggerate and take too much time from your precious time. You need to go to work again. Thank you for taking this hour and even extend it by 10%. Thank you very much. And everyone who is interested in getting to know more, you can either watch the YouTube channel of James Tour. He has a marvelous YouTube channel, especially on chemical issues. And if you want to get more interaction with other Christian academics, there are quite a few networks, like, for example, at the European Leadership Forum. As I explained at the beginning, there's the Science Network, the Theologians Network, the Academics Network. Feel free to register and join the conference in May, or to take part in the year-round mentorings. You will find all of that on the website. And then there is a Lausanne network, and there are many other networks that are also represented here. IFES has different networks for Christians who want to share their testimony and their faith at the university.